Learning objectives. In this chapter, the user would be learning about advanced programming constructs and the following in detail: sub-procedures, function procedures, modules, arrays, structures, collections. Procedures. A procedure is a group of statements that together performs a task when called. After the procedure is executed, the control returns to the statement calling the procedure. VB.NET has two types of procedures: functions, sub-procedures or subs. Functions return a value, whereas subs do not return a value. Sub-procedures. The sub statement is used to declare the name, parameter, and the body of a sub-procedure. The syntax for the sub-statement is where modifiers specify the access level of the procedure. Possible values are public, private, protected, friend, protected friend, and information regarding overloading, overriding, sharing, and shadowing. Subname indicates the name of the sub. Parameter list specifies the list of the parameters. Example for sub-procedure. The following example demonstrates a sub-procedure, calculate pay, that takes two parameters, hours and wages, and displays the total pay of an employee. The example program shows how to calculate pay by taking the parameters such as hours and wages using sub-procedure. Here the procedure calculate pay is the sub-procedure where local variables are declared. At the end of the sub-procedure, the main function is stated. It calls a procedure by different parameters. Passing parameters by value. This is the default mechanism for passing parameters to a method. In this mechanism, when a method is called, a new storage location is created for each value parameter. The values of the actual parameters are copied into them, so the changes made to the parameter inside the method have no effect on the argument. In VB.NET, you declare the reference parameters using the by-val keyword. The following example demonstrates the concept. The following example illustrates passing parameters by value. Passing parameters by values is the default method in any language. Here the parameter is passed directly to the function. It shows there is no change in the values, though they had been changed the function. Passing parameters by reference. A reference parameter is a reference to a memory location of a variable. When you pass parameters by reference, unlike value parameters, a new storage location is not created for these parameters. The reference parameters represent the same memory location as the actual parameters that are supplied to the method. In VB.NET, you declare the reference parameters using the by-ref keyword. The example program shows how the procedure is called by passing parameters by reference. The parameter passing is located by same memory location. The pointer concept is used in this method. Defining function. Function is a group of statements. It should be executed once called. The function call is referred by a value or by a reference. The function statement is used to declare the name, parameter, and the body of a function. The syntax for the function statement is where modifiers specify the access level of the function. Possible values are public, private, protected friend, and information regarding overloading, overriding, sharing, and shadowing. Function name indicates the name of the function. Parameter list specifies the list of the parameters. Return type specifies the data type of the variable the function returns. Here is an example for function. Following code snippet shows a function findMax that takes two integer values and returns the larger of the two. The function name is findMax. It is called by the value. The program is an example of finding the biggest number among a set of given numbers. Function returning a value. In VB.NET, a function can return a value to the calling code in two ways: by using the return statement, by assigning the value to the function name. The following example demonstrates using the findMax function. The example shows how to return a value from a function. For returning, the sub-function is executed. When the code is compiled and executed, it produces the following result. Recursive function. A function can call itself. This is known as recursion. Following is an example that calculates factorial for a given number using a recursive function. Function call means that the function is called as recursive function. Here's an example that shows the recursive function by calculating the factoid for the given number. The result for the program is shown here. Param arrays. At times while declaring a function or subprocedure, you're not sure of the number of arguments passed as parameter. VB.NET param arrays come in to help at these times. The following example demonstrates this. Param array is also called as dynamic array. When we don't know the number of arguments passed as a parameter, when declaring an array, we can use param array. The example program shows how to use param array. The result of the program is passing arrays as function arguments. You can pass an array as a function argument in VB.NET. The following example demonstrates this. One special feature in VB is passing an array as a function argument for a function or procedure. The example shows a syntax for passing an array as an argument. The result of the program is shown here. Modules. A VB.NET program is made up of variables and programming statements enclosed in a module. The simplest way to understand this is just to realize that variables and programming statements need to be grouped together by something. This something is called a module. VB program is a set of two modules. They are variables, programming statement. A variable is nothing but a name given to a storage area that our programs can manipulate. Each variable in VB.NET has a specific type, which determines the size and layout of the variable's memory, the range of values that can be stored within that memory, and the set of operations that can be applied to the variable. Declaring variables. Before you can use a variable in a program, it has to be declared. To declare a variable, you use the dim keyword and specify a data type list in the preceding data type table. In this example, X is declared as a variable of integer data type. Dim means declare variable, as means specify a data type. The dim statement is used for variable declaration and storage allocation for one or more variables. The dim statement is used at module, class, structure, and procedure or block levels. Syntax for variable declaration in VB.NET is: attribute list is a list of attributes that apply to the variable, optional. Access modifier defines the access levels of the variables. It has values as public, protected friend, and private, optional. Shared declares a shared variable which is not associated with any specific instance of a class or structure, rather available to all the instances of the class or structure, optional. Shadows indicate that the variable redeclares and hides an identically named element or a set of overloaded elements in a base class, optional. Static indicates that the variable will retain its value even when the termination of the procedure in which it is declared, optional. Read-only means that the variable can be read but not written, optional. With events specifies that the variable is used to respond to events raised by the instance assigned to the variable. Variable list provides the list of variables declared. Each variable in the variable list has the following syntax and parts. Variable name is the name of the variable. Bounds list, optional. It provides a list of bounds of each dimension of an array variable. New, optional. It creates a new instance of the class when the dim statement runs. Data type, a must requirement. It specifies the data type of the variable. Initializer, optional if new is not specified. Expression that is evaluated and assigned to the variable when it is created. Some valid variable declarations, along with their definition, are shown here. Dim student ID as integer, dim student name as string, dim salary as double, dim count 1, count 2 as integer, dim status as boolean, dim exit button as new system.windows.forms.button, dim last time, next time as date. Variable initialization in VB.NET. Variables are initialized, that is, assigned a value, with an equal sign followed by a constant expression. The general form of initialization is, for example, to initialize a variable, we first found the sign and then the constant. The syntax shows how to initialize variables in VB.NET. This is a common method for all high-level languages. You can initialize a variable at the time of declaration as follows. Example for variable declaration and variable initialization. The program shows how to declare the variables and how to initialize the variables. When the code is compiled and executed, it produces the following result. Accepting values from user. The console class in the system namespace provides a function readline for accepting input from the user and storing it into a variable. For example, these static programs accept the given input, no different output would be produced. The syntax has been created to give the input on running time. The example shows how to declare a variable for runtime initialization. When the code is compiled and executed, it produces the following result. L values and R values. There are two kinds of expressions. L value, an expression that is an L value, may appear at either the left-hand or right-hand side of an assignment. R value, an expression that is an R value, may appear on the right but not left-hand side of an assignment. Example: VB.NET sample program. We are now ready to write our first VB.NET program. In this sample program, we will initialize some variables and print their values to the screen. Programming languages use programming statements to do things. A statement includes command words called keywords and data values. Our statement will be a statement that allows you to print out messages on the computer screen. Messages are string constants enclosed by double quotes like hello. This is a console program, meaning the output is sent to the screen and the user types in the input responses. A console program is a little different from a GUI program. In our program, we first declare name and age variable, dim name as string, dim age as integer. We then initialize name to Tom and age to 20. Now we want to print the name and age to the screen. We use the console.write and console.writeLine statements to do this. Here we print, "Hi, my name is Tom," message on the computer screen. Example program. You will notice it is enclosed in a module and a sub called main. The sub encloses the programming statements. The module encloses the submain. A module can have many subs. The main sub is the first sub to start executing in a module contained in a program. Step-by-step instructions to run the program. Before you can write and run this program, you first need to create a new project. Make sure you have Visual Basic.NET installed on your computer. We are using Visual Basic.NET version 2008. Step 1. Opens up Visual Basic.NET from the File menu, select New and then Project. Step 2. Right-click on Form 1 in the Project Explorer window and select Remove Form 1 from the pop-up window. This is an optional step. Step 3. You should make a directory for your program using Windows Explorer and use the Browse button to select that directory. Select Console Application and then type in the name of the program. Step 4. Now type in the program. Step 5. To run the program, select Start from the Debug menu. Array. An array is a collection of data stored in the continuous order. It is a linear data structure to access the data. An array stores a fixed-size sequential collection of elements of the same type. An array is used to store a collection of data, but it's often more useful to think of an array as a collection of variables of the same type. All arrays consist of contiguous memory locations. The lowest address corresponds to the first element and the highest address to the last element. Creating arrays in VB.NET. To declare an array in VB.NET, you use a dim statement. The example shows how to create, access, and operate the array. Dim is used to declare the array. The value may be declared at the access time or at the run time. The elements in an array can be stored and accessed by using the index of the array. The following program demonstrates this. This is the sample code for declaring and accessing the array. The console is to write the program in the output box. It is a program to print from 100 to 110 using for loop. When the above code is compiled and executed, it produces the following result. Dynamic arrays. Dynamic arrays are arrays that can be dimensioned and redimensioned as per the need of the program. You can declare a dynamic array using the redim statement. Syntax for redim statement, where The preserve keyword helps to preserve the data in an existing array when you resize it. Array name is the name of the array to redimension. Subscript specifies the new dimension. Sample program. In dynamic array, the length should be declared dynamically. It is declared by using redim statement. No special reason for redim. It's a syntax used for dynamic array declaration. It produces the following result. Multidimensional arrays. VB.NET allows multidimensional arrays. Multidimensional arrays are also called rectangular arrays. You can declare a two-dimensional array of strings as a three-dimensional array of integer variables. The following program demonstrates creating and using a two-dimensional array. When the code is compiled and executed, it produces the following result. Jagged array. Declaring an array using a defined array is called a jagged array. A jagged array is an array of arrays. The following code shows declaring a jagged array named scores of integers. The following example illustrates using a jagged array. When the code is compiled and executed, it produces the following result. The array class. The array class is a base class for all the arrays in VB.NET. It is defined in the system namespace. The array class provides various properties and methods to work with arrays. Properties of the array class. Is fixed size gets a value indicating whether the array has a fixed size. Is read-only gets a value indicating whether the array is read-only. Length gets a 32-bit integer that represents the total number of elements in all the dimensions of the array. Long length gets a 64-bit integer that represents the total number of elements in all the dimensions of the array. Rank gets the rank, number of dimensions of the array. Methods of the array class. Sets a range of elements in the array to 0, to false, or to null, depending on the element type. Copies a range of elements from an array starting at the first element and pastes them into another array starting at the first element. The length is specified as a 32-bit integer. Copies all the elements of the current one-dimensional array to the specified one-dimensional array starting at the specified destination array index. The index is specified as a 32-bit integer. Gets a 32-bit integer that represents the number of elements in the specified dimension of the array. Gets a 64-bit integer that represents the number of elements in the specified dimension of the array. Gets the lower bound of the specified dimension in the array. Gets the type of the current instance, inherited from object. Methods of the array class. Gets the upper bound of the specified dimension in the array. Gets a value at the specified position in the one-dimensional array. The index is specified as a 32-bit integer. Searches for the specified object and returns the index of the first occurrence within the entire one-dimensional array. Reverses the sequence of the elements in the entire one-dimensional array. Sets a value to the element at the specified position in the one-dimensional array. The index is specified as a 32-bit integer. Sorts the elements in an entire one-dimensional array using the I-comparable implementation of each element of the array. Returns a string that represents the current object, inherited from object. Example, the following program demonstrates use of some of the methods of the array class. This is a sample program using the array class methods. All the methods are not implemented, only the most important methods are implemented. Result of the program. Control flow. In a program, statements may be executed sequentially, selectively, or iteratively. Every programming language provides constructs to support sequence, selection, or iteration. So there are three types of programming constructs: sequential constructs, selection constructs, iterative constructs. Sequential construct. The sequential construct means the statements are being executed sequentially. This represents the default flow of statements. In this construct, the program starts at a point and goes in a sequential flow. It does not contain any jump statements. It's the default control in high-level language. Selection construct. The selection construct means the execution of statements depending upon the condition test. If a condition evaluates to true, a course of action, a set of statements is followed. Otherwise, another course of action is followed. This construct is also called a decision construct, as it helps in decision making. The conditions determine the controlling execution. For example, jump A. If the statement executes, the next step will move to statement A. Iterative construct. The iterative or repetitive construct means repetition of a set of statements depending upon a condition test. A set of statements are repeated again and again till the condition or Boolean expression evaluates to true. The iteration constructs are also called as looping construct. The looping statement determines the controlling execution. There are many iterative statements, for example, for, while, incremental, decremental statements. The Boolean expressions are used for evaluating true. Selection constructs. There are two types of selection construct in VB, like in other high-level languages. They are if statement, select case statement. If statement. The if statement of VB comes in various forms and are given. If then statement, syntax. An if then statement tests a particular condition. If the condition evaluates to true, a course of action is followed. Otherwise, it is ignored. If then else statement, syntax. If then else statement provides an alternate choice to the user. That is, if the condition is true, then a set of statements are executed. Otherwise, another set of statements is executed. If then else if statement, syntax. If then else if statement is used to test a number of mutually exclusive cases and only executes one set of statements for the case that is true first. Nested ifs. A nested if is an if that has another if in its ifs body or in its else's body. The nested if can have one of the following three forms. Select case statement. Select case is a multiple branching statement and is used to execute a set of statements depending upon the value of the expression. It is better to use select case statement in comparison to if. Then else if statement when the number of checks are more. The conditions determine the controlling execution. For example, jump A. If the statement executes, the next step will move to statement A. Different forms of select case. Select case, simplest form, exact match. Select case expression, case value, one or more Visual Basic statements. Case value, one or more Visual Basic statements. Case else, one or more Visual Basic statements. End select. Example. Different forms of select case. Select case, second form, relational test. Select case expression, case is relation, one or more Visual Basic statements. Case is relation, one or more Visual Basic statements. Case else, one or more Visual Basic statements. End select. Syntax of Form 2. Example. Different forms of select case. Select case, third format, range check. Select case expression, 1 to expression 2, one or more Visual Basic statements. Case expression 1 to expression 2, one or more Visual Basic statements. Case else, one or more Visual Basic statements. End select. Third form of select case. Example: iterative constructs, that is, looping structures. Loop. A loop is said to be a set of instructions which are repeated again and again in a program. Types of loops in VB: sentinel control loop structures, repeat statements until a special value called sentinel value or the terminating value is reached. Counter control loop structures repeats a set of statements until the value specified by the counter variable is reached. VB offers broadly the following three types of looping structures: for, next, do loop, do while loop, do loop while, do until loop, do loop until, while, when. For, next statement. Syntax: this type of statement is used when the user knows in advance how many times the loop is going to be executed. Do while loop. Syntax: do while loop is an entry control loop in which the condition is placed at the entry point. This statement executes a statement specified in the body of the loop till the condition evaluates to true. The loop may not be executed at all if the condition is initially false. Do loop while. Syntax: do loop while is an exit control loop as a condition is placed at exit point. The body of the loop is going to be executed at least once, whether the condition evaluates to true or false. Loop is executed as long as the result of the condition remains true. Do until loop. Syntax: do until loop is an entry control loop in which the condition is placed at the entry point. This statement executes a statement specified in the body of the loop till the condition evaluates to false. The loop may not be executed at all if then condition is initially true. Do loop until. Syntax: do loop until is an exit control loop as a condition is placed at exit point. The body of the loop is going to be executed at least once, whether the condition evaluates to true or false. Loop is executed as long as the result of the condition remains false. While, when loop. Syntax: while, when loop is functionally equivalent to the do while loop. It executes a set of VB statements till the condition evaluates to true. Collections. Collection classes are specialized classes for data storage and retrieval. These classes provide support for stacks, queues, lists, and hash tables. Most collection classes implement the same interfaces. Collection classes: allocating memory, elements, and accessing, indexing. Collection classes serve various purposes, such as allocating memory dynamically to elements and accessing a list of items on the basis of an index, etc. These classes create collections of objects of the object class, which is a basic class for all data types in VB.NET. Various collection classes and their usage. Array list represents ordered collection of an object that can be indexed individually. Hash table uses a key to access the elements in the collection. Sorted list uses a key as well as an index to access the items in a list. Stack represents a last-in, first-out collection of object. Queue represents a first-in, first-out collection of object. Bit array represents an array of the binary representation using the values 1 and 0. Collection classes. Array list. It represents ordered collection of an object that can be indexed individually. It is basically an alternative to an array. However, unlike array, you can add and remove items from a list at a specified position using an index, and the array resizes itself automatically. It also allows dynamic memory allocation, add, search, and sort items in the list. Hash table. It uses a key to access the elements in the collection. A hash table is used when you need to access elements by using key, and you can identify a useful key value. Each item in the hash table has a key value pair. The key is used to access the items in the collection. When the code is compiled and executed, it produces the following result. Sorted list. It uses a key as well as an index to access the items in the list. A sorted list is a combination of an array and a hash table. It contains a list of items that can be accessed using a key or an index. If you access items using an index, it is an array list, and if you access items using a key, it is a hash table. The collection of items is always sorted by the key value. When the code is compiled and executed, it produces the following result. Stack. It represents a last in, first out collection of objects. It is used when you need a last in, first out access of items. When you add an item in the list, it is called pushing the item, and when you remove it, it is called popping the item. When the code is compiled and executed, it produces the following result. Queue. It represents a first in, first out collection of objects. It is used when you need a first in, first out access of items. When you add an item in the list, it is called enqueue, and when you remove an item, it is called dequeue. When the above code is compiled and executed, it produces the following result. Bit array. It represents an array of the binary representation using the values 1 and 0. It is used when you need to store the bits but do not know the number of bits in advance. You can access the items from the bit array collection by using an integer index which starts from 0. When the above code is compiled and executed, it produces the following result. Conclusion. In this chapter, the user would have learned about advanced programming constructs and the following in detail: sub-procedures, function procedures, modules, arrays, structures, collections.